This is Natural Selection Lesson 2.2. You should have just completed the warm-up for this lesson. If you have not done the warm-up yet, please go back and do it, or you might be a little confused on this video. Also, there is a teacher version in between activities 1, 2, and 3, and then look, another teacher. So you will not see this on your version of Amplify. So good on you if you're watching this right now. You are one of the select few people who actually follow instructions. So good job. Anyways, we are going to look at the traits in reproduction sim. So in the warm up, you saw um, some spiders, and so that came from the unit traits in reproduction, which the current 8th graders did not get to do. The 7th graders, I don't think they did it last year either, so it's just the 6th graders that did it this year. It's just the way it worked out. Anyways, some of you are excited you didn't have to do it because spiders scare you, and then some of you are probably going to see this and think that, man, I wish I could do it. So you have access to this sim, I believe. If not, I'm sorry, I'm not sure. I think you have access to the sim if you were to go on your regular Amplify. Um, I think you have it in here, but I'm not sure. Anyways, so we're going to look at it now. But first, yesterday or in the last lesson last week, you read about glowing jellies and the protein molecule that leads to that trait. So we are going to begin our lesson today by looking at another kind of organism and explore a model of how individuals in a population get their traits. We'll be focusing on the feature of stripe color in a population of spiders. So we'll have Otis here, and we have Ruby here. We're going to be focusing on Otis and Ruby in this video. So Otis is brown and has a blue stripe. So his traits are brown body, blue stripe, and a little bristle or hair. Um, and Ruby's traits are that she has a yellow body with a black stripe and a lot of bristle or hair. So we are going to focus on these two spiders. We're going to look at their genes for stripe color and how they lead to protein molecules and therefore traits. Then we're going to look at their offspring and see how the traits were passed down. So what I'm going to do is I'm going to select stripe color at the top, and then I'm going to press on Otis, and we can see a model of his cells over here. So these pink shapes are protein molecules, and you should notice that they fit together with other molecules in the cell, and together they produce blue pigment. So you can see they have a certain shape, and then there's certain areas that they fit into. And these, when you watch it, you should see that you could see these blue pigment coming out of it. And so here's a possible proteins, the different shapes here. So when they fit together, they produce blue pigment. This is how protein molecules lead to the blue stripe trait. So if we look at his genes, which are up here, genes are found on chromosomes, and there are 2 copies of every gene. These copies can be the same version or different version. Otis has 2 of the same version, which is T2. This version of the gene gives the cells the instructions to make the protein molecules that lead to blue pigment. So now I'm going to look at Ruby, and if we look on her chromosomes, she also has 2 copies of the gene for stripe color, but her copies are not the same. She has 2 different versions. She has T2 and T3. Different versions of a gene are also called alleles. Notice that she has one version of the gene that is the same as Otis. The T2 gene gives the cells instructions to make the protein molecule that leads to blue pigment. So again, we can see here this looked just like Otis. So she is producing blue pigment because she has the same T2 gene that Otis has. She also has another version of the gene that is T3. This is still the gene for stripe color, but the protein molecule that is produced is a different shape. It's pointy instead of round, and so you can see 3 here, and like this, pointy instead of round, but it's producing black. So because of its different shape, it fits together with a different molecule and produces black pigment instead. Black pigment mixed with blue pigment produces a black color, so her stripe is black. Black dominates over blue, and so she has a black stripe that you can see. All right, so let's go back to Otis. So this simulation will allow us to change, the simulation will allow us to change the genes of Otis and see what happens to his protein molecules. Actually, yeah, I did want to be in there. In real life, organisms cannot just change their genes, but this is a model that can help us see what happens when we change the genes. So what do you think will happen if I change one of his gene copies, remembering it has 2 the same, T2, what if I change one of them to T3, the same version that Ruby had? Well, you're probably thinking, well, if I change one to T3, it'd end up being the same as Ruby because she had a T2 and a T3. So if I change one of these to T3, I would expect to see that she ends up having a black stripe, or he. So, and then that's what happens. You notice over here that first of all, we're getting the 2 different protein structures, the rounded T2 and the pointy T3. And then we're getting the 2 different pigments, the blue and the black, and black dominates the blue, and so Otis now has a black stripe. Okay, so I'm going to change him back to his original genes. And then what I'm going to do is I'm going to drag Ruby and Otis together, and I'm going to they're going to mate. So I've dragged them together, and so the question is, if Otis and Ruby have offspring, what color stripes do you think they will have? Well, they have black, one has black, one has blue, so it would make sense that we think that some might have black, some might have blue. So I'm going to press skip to offspring down here, and I'm going to press on a spider with a blue stripe. So I'm going to click on this spider, and we're in stripe color. So this spider has 2 copies of the T2 version of the gene. One came from Otis, and one came from Ruby. One came from one parent, and one came from the other parent. Organisms get their genes from their parents. So the protein molecules in the cells, we can see, are the rounded ones. So the genes are giving instructions for making protein molecules. So the T2, these 2 genes are saying you need to make these protein molecules, the rounded ones. And then the protein molecules lead to the traits. So the genes give the instructions to the protein molecules to make the protein molecules, and then the protein molecules, when they react with these other molecules, they make the blue pigment, and that's what gives them their traits. All right, now I'm going to click on a spider with a black stripe, and we can see that the spider has 2 different versions of the gene. It has the T2 and the T3. T2 came from Otis, because remember Otis had 2 T2s, and T3 came from Ruby, because Ruby had a T2 and a T3, so T3 had to have come from Ruby. So the cell has instructions to make both protein molecules. And so you see the rounded T2 protein molecule, or the 2-shaped protein molecule, and the 3-shaped protein molecule, the pointy one. So the cell produces blue and black pigment, and then the black sort of dominates. When you mix black and blue, you just get black. So we have a black stripe. Okay. So you guys can, I hope you can see this sim, and I'm sorry if you can't. But anyways, let's go back to this activity, because now we have a key concept, 2 of them. So genes are instructions for making protein molecules, and protein molecules determine an organism's traits. Individuals inherit their genes from their parents. Genes, and therefore traits, in a population are passed down from one generation to another generation. So this is important because this is why when we look at the modeling tools, so if I pull up one of the modeling tools, let's see, I'm not gonna look at the modeling tool for the write and share routine that you're supposed to do last week or a couple weeks ago. This is why this key concept that genes are passed down from their parents. This is why when you have an initial population, if these traits of 8, 9, and 10 do not exist in the initial population, they can't be passed down on to future generations. You can't just all of a sudden 50 generations to like show these traits existing. It can't happen because they have to be passed down. That's what these key concepts are telling us. So in the sim, we can see that the structure and the shape is of the protein molecule determines its function. If it is a rounded shape, its function will be to produce this blue pigment. If it is a pointed shape of the 3, it will produce a black pigment. It basically the structure determines what the protein molecule does. So this is important because this is one of our cross-cutting concepts, the way of thinking that like certain shapes create certain functions. And so this is really important when we're talking about traits and protein molecules, and the action of a certain shape of a protein molecule leads to a certain trait. All right, that is it for this video.